Okay, electromagnetics is the study of waves. So anything in electricity that does not just stay on a wire is electromagnetics. Some of the applications of that are antennas, such as communication, your cell phones, your iPods, radio, television, satellite communication. Some of those are ranging, being able to find distances, like GPS is one of the most famous applications of that right now, and also radar. So being able to find distance or communicate, those are physical things that electromagnetics does. It also does a lot of sensing. So if you wanted to be able to tell if a peach is ripe, for instance, electromagnetics is able to do that. Now, you may also be able to taste the difference, but being able to use electromagnetics as a sensor is very common. There are many radar-type sensors that are used for electromagnetics. It's also important in imaging. So being able to do MRI images or CAT scans or ultrasound images, those are all the types of things that someone in electromagnetics may build or study. And there's a lot of technology going on right now to do better medical images. So that's one of the really cool applications of electromagnetics today. There's also a lot of medical activity, being able to use it to create devices that help people heal. There's pain stimulation devices, so if you have intense pain that can't be taken care of well with medicine, you may use a pain stimulator, which just overstimulates your nerves without really hurting you, so that your nerves don't respond with this pain that's hurting you.
That's nice.
Or if you have a bone that's not properly healing, particularly in elderly people, sometimes it just will quit healing. It'll just sit there. You can use pulsed electromagnetic fields around that bone. It doesn't hurt the person, but you just put a stimulator on at night, and that can often stimulate bone growth. Same thing with muscle and soft tissue repair. So there are a lot of medical devices that rely on electromagnetics also. So electromagnetics is a very broad field. Sometimes it's really tiny, like the teeny tiny circuits that are used in communication systems, or sometimes it's really big, like the big satellite communication systems. It's probably an application of physics, and then math is used as a tool.
Okay.
Biology, chemistry, even some physics, those are all things that help us with application, but I don't use much chemistry in my day-to-day work. And I don't really use much biology in my day-to-day work, except in the application. Electromagnetics, again, is so broad, and besides the ones that I've mentioned in bioelectromagnetics, in imaging, also include optics in your analysis of electromagnetics, because the techniques that are used in optics and the techniques that are used in plain electromagnetics are very, very similar. So we also consider optics to be a part of electromagnetics. So I would say the range of what you can do with electromagnetics is tremendous. You can do communication, you can do high-speed integrated circuits, you can do many creative kinds of communication, you can do imaging, you can do sensing, you can do ranging. Electromagnetics is a very, very powerful